Today I'm going to solve the LeetCode question number 15, threesome. Given an integer array nums, return all the triplets such that, so basically make sure none of a value isn't reused twice or 3 times. And nums I plus nums j plus nums k equal to 0. Note that the solution set must not contain duplicate triplets. So a naive approach is to have a triple nested loop. So for example, if we're looking at 1 minus 1 here, we loop through the rest of the array, and then we have another focus of 0 here, and then we loop through the rest of the array. So minus 1 plus 0, and then 1, so that's a possible combination. We also have minus 1 and 2 and minus 1, so that's another combination, but this would be triple nested and O of n cubed, and we can do better than that. How's it O of n cubed? So you have minus 1 here, and then we loop through the rest of the array, so it'd be like 0, 1, 2, minus 1, minus 4. We look at this guy initially, and then after this guy we loop through the rest again, 1, 2, minus 1, minus 4, and then we find out, oh, these 3 equate to 0. And similarly, if we're still at this minus 1 here, we can look at 1, and then for this one, we look at everything after that, and then 1 minus 1, 0, 2, they do not equate, okay, and yada yada yada, and then after this minus 1, we look at, or after this one, we look at 2, and then look at everything after 2, and then actually minus 1, 2, and minus 1 here equate to 0, and so that's part of the result set. But again, this is triple nested, and we can do better. Okay, so how can we do better? Well, we can use, if you solved the two-sum before, at the problems two-sum and two-sum 2, so two-sum and two-sum 2, this problem can actually derive from these two problems. So if we have, but first off, no solution set must not contain triplets. So how do we prevent duplicates? Well, we can sort this array so that all the duplicates are grouped together. So for example, we have minus 1, minus 4, we're sorting it, minus 1, and 0, 1, 2. So all the duplicates are grouped together, and if we have pointers, we can easily skip over these duplicates. So how can we implement the two-sum solution? So what we can do is, looking at a focus element in focus here, so like minus 4, and since this is sorted, we can use the strategy we use in two-sum 2 with the start pointer and end pointer to check if these 3 equal to 0. If they're greater than 0, then obviously we need one of these values to be smaller. So we move this guy here. And if it's less than 0, we want one of these values to be bigger, and since it's sorted, if we move to the right here, we get a bigger value. This is a duplicate, so we're going to handle this and skip over to look at this next value here. And we're going to do this pointer method until while start position is less than the end position, of course. We can see with -4, there's no solution where they all equal to 0, where there are 3 numbers that equal to 0. But let's look at the case of -1. So this is our value in focus, and then we have our start pointer here and end pointer here. So we see they actually all do equal to 0, so we're going to add this to our result. -1, -1, 2. Awesome. We're still going to continue with our pointers here, just to check if there are no other values. So we're going to shift our sorry, 1 second. We're going to shift our left pointer. We only have to move 1 pointer here to this guy. -1 plus 0 plus 2. It's actually greater than 0, so we're going to shift this guy over here. And we see this is another possible solution. So we're going to record that -1, 0, 1. Oops. Okay. And we're going to do the same thing for the rest of the array. To have the next guy be in focus, we'll move these pointers here. Have this next guy be in focus. And this guy is actually the same as this one. And if we do the pointer method with this one, then we will get duplicate results. So we're just going to skip over it to 0. So this guy will be in focus, not this one. And here's our left and right pointer. And while left is less than right, we check if there are any results where all 3 numbers equal to 0. In this case, not so much. I'll do the same for the rest here. And yeah, that's kind of basically our approach with threesome. So our time complexity is going to be O of n squared, because we're going to look at each element. Each element is going to be a focus, and then we're going to do the 2-pointer method for every element after the element in focus. So if we're looking at -1, this isn't sorted, but we're going to look at every other element here. If this is a focus, then we're going to look at every element here, and it's going to be O of n squared. So we must sort this first to avoid those duplicates, duplicate triplets. Okay. Sort. So after this, our array will look like -4, -1, -1, 0, 1, 2. Okay. And nums is guaranteed to be at least 3, so we don't have to can't handle the case where nums is less than 3. Nums dot length is less than 3. Otherwise, there would be no solution there because you don't have triplets to make. Okay. So what we're going to do is initialize our result variable and then iterate through nums. So for position value in enumerate nums, we're going to have our left pointer to be position +1 and right pointer to be at the very end of nums. Okay. And while left is less than right, we're gonna have our current total to be equal to val plus nums at the left corner plus nums at the right corner. Okay. If p is equal to 0, great, we have a solution. Actually, I want to. If p less than 0, then obviously we have to move our left pointer to the right because we want a larger value for our triplet. If p greater than 0, our current total, if I'm calling it p, right, minus equals 1, because obviously we want a smaller value, do an elif here. Okay, that's easy enough. So else, if the current total is 0, we found the result. So result.end. It's going to be a 2D array result, so it's going to be val nums left and nums right. Okay. So once we found that, so like we're here, we found our first solution of -1, 0, and 1 here. So we want to continue on, find out if there's another solution. And how we can do that is just increment this left pointer. So right now would be here, left pointer. Oh, it would be here and it would be here by 1. Okay. What if this guy was like -1 here, and this is not going to make any sense, but like we have -1, and this 2 as a focus. If we increment our left pointer, we're going to look at this guy, and if these 3, that was just our solution, we'll have these 3, which is a solution again. Again, they don't equal to 0, I'm just using this as an example. So what we're going to have to do is increment the left pointer until we don't see the current value of the left pointer again. So this was part of our solution, and we increment here. This was already part of our solution. We don't want duplicate values, so we're going to move this again. This is different, so we're just going to leave it here. And that's what we're going to do. And we're not going to change the right pointer because our loop here will already take care of the right pointer. So if we have like 2, 2, 2, whatever, and we took it a care of the case where we incremented our left pointer till we don't see duplicates anymore. So our left pointer is here and right pointer is here. We obviously see that so this would be a solution, -1, 1, that wouldn't be a solution. So anyway, we obviously see that -1 plus 1, 0, plus 2, 2 is greater than 0. So we're going to just decrement the right pointer and decrement. So it's obviously just going to skip through all these. Anyway, with our current loop, we don't have to decrement the right pointer and to specifically take care of duplicates. Hope that made sense. Okay. And then after we append the result, so So left val equal to nums left, and while nums left equal to left val and left is less than right. So we want to make sure left is less than right corner. We don't want to go out of bounds or anything. And increment the left corner. Okay. Great. And actually, this would be better. It'd be ln nums initialize I equals 0 here. Why did I do this? Well, again, with the duplicates. So if we have like this example, -4, -1, -0, 1, 2. We already found the solution for -1, 0, and 1, and -1, and -1 and 2. So now we're going to shift our focus element, but we shift it here. And we don't want it here, or else we get duplicate values of -1, 0, and 1 again. So we're just gonna shift, like with this up pointer here, shift our focus element in focus until we don't see it again. So we're gonna, until it's different. So we're gonna move to 0 here. Okay. So I'm gonna have to replace okay, and while I is less than nums, because you don't want to go bound, and nums I equal to val, just increment I. And finally, once we're all done, we should return result. Okay, well, let's try compiling it. Oops. And again, this is O of n squared time. Oh, same one. Oh, position. It should be I plus 1 because I just changed it. Okay. And I'll just test with the rest of the cases. Okay, and I'll try submitting. Okay, awesome, and thanks for watching.